Alright, so we're going to do number 7 on your optimization sheet. Perimeter is given of a rectangular window with a triangle part on top of it. So we're going to call this isosceles. Okay, we're going to call this triangle isosceles, and this is just a rectangle. And what we want is this is a window. It's made up of a triangle and a rectangle. And we want this window to let in as much light as possible. Oops. So we want to maximize area. Okay, but we're given a fixed perimeter. P is equal to 20 feet. All right. So here's where we take off. All right, we know we want to maximize area, so our primary equation is going to be area is equal to let's just say for general purposes, length times width plus 1/2 base times height. Okay, base times height. I think I said base times base right there. Sorry. But let's label this in as a few. Let's label this in as few variables as possible. So let's say we call this x, and let's say we call this h. Okay. Well, that means this would be x as well, and this would be h as well. Okay. And that means that, well, okay, hold on just a second. This is an isosceles triangle. Okay? Isosceles triangle, let's see, that's 45, 45, 90. Okay? So what we would do is right here we would just try to go ahead and understand. All right? Let's say we have an isosceles triangle, and we can use the we can use the Pythagorean theorem to figure out an isosceles triangle right here, because this is x and this is x and this is something. Okay. All right. So, well, actually, the other way around. Let's make this a and this a, and that's already x. So let's make that x. Okay. So so a squared plus a squared equals x squared. Okay. Well, that's 2a squared equals x squared. Okay. Now what we want to do is we want to find out what these a's are. That's what we want to do. We want to find out what a is in terms of x, because that's the part we're missing right here. We're missing that. We don't know this. Okay, so let's go ahead and do that. Divide by 2. A squared equals x squared divided by 2. So a squared. Okay, square root both sides. You'll have a is equal to the square root of x squared over 2. So a is equal to x over the square root of 2. Now, it only takes a little bit of remembering your 45, 45, 90 rules, or just even the Pythagorean theorem. If you remember your 45, 45, 90 rules, you could take a look at it like this. You could say, let's see, let me go ahead and zoom in. You could just, if you know your 45, 45, 90 rules, you could say, well, we know that this is x, and this is square root of 2x. Okay, that's square root of 2 times x. Well, if we're given this, alright, then if we're given x, square root of 2x, well, since this is already multiplied by the square root of 2, alright, then we would know if we're given this as x, it's already been multiplied by the square root of 2, so you know you would need to divide both of these by the square root of 2. Alright, but at any rate, whether you use the Pythagorean theorem or basic 45, 45, 90, 45, 45, congruent, 90 degree angle rules, you can find out a formula for the sides. So now that we have that, let's fill that in. Okay, this is x over the square root of 2, x over the square root of 2. I'm sorry, that's small. That's super small. Sorry, guys. Let me see if I can zoom in just a tad bit more. Alright. So, now the next thing we have to write is this right here. Okay. Alright, so that's the height. Okay. So let's find the height in terms of x. Alright. Well, let's see. Now, if this is 90, and that's 90, then that's 45. Well, we have another 45, 45, 90. Well, that means that this is isosceles. Okay, so those two are congruent. If it's a 45, 45, 90, it's isosceles. So this is this piece right here. The height is the same as that piece right there. So that means it's, once again, it's isosceles. So yeah, we have a 45, 45, 90. I forgot to say it's an isosceles right triangle. Right triangle. My bad, guys. So that means that's 90, and this would bisect it, causing it to be 45, 45, 90. So it's isosceles, so that's half of x. So this would be 1/2 x. Would be the height of that triangle. Uh-oh. Alright, my pencil's failing on me. Come on, pencil. Come on. Oh, there we go. There we go. Alright, so that's 1/2 x is the height. Okay? So, let's go ahead and label these. Well, the area of the rectangle was length times width, but we switched it to x times h. So let's let that be that. X times h plus 1/2. What's the base of the triangle, the big triangle, the whole thing? The base of the whole thing is x times the height of the triangle. Well, we figured the height of the triangle, since it was an isosceles right triangle, okay, the isosceles right triangle, it's going to be 1/2 x. Okay. Wow, 1/2 x times 1/2 x. That's not too bad. Okay. Now, all right. So, given this here, okay. So let's simplify it. xh plus 1/2. Actually 1/4 x squared. Okay. Alright, so that's what we have right there for our primary equation. Notice we have an issue. We've got, once again, 3 variables, 1, 2, 3, and we can't take the derivative. So let's use our secondary equation. Our secondary equation is the perimeter. So the perimeter is equal to 20 feet. Now the perimeter, let's see what we add up here. We add up x plus h plus x over square root of 2 plus x over square root of 2. So x plus, well, not x plus h, x is x plus h plus h. So x plus 2h plus 2 of these x over square root of 2's. So plus 2x over root 2. And there's our perimeter formula. Well, we know we have a 20-foot perimeter, so that's 20 equals x plus 2h plus 2x over the square root of 2. Alright, now we're going to solve for h. We're going to solve for h, and we're going to substitute it back in here once we're done solving. So I'm going to go ahead and put a star on it because I know I'm going to plug in something for that. Alright, so I'm going to have to cut this video in half and finish it later. And I will talk to you guys later on the second part.